Okay. So for naive Bayes, we can use the same frequency table from here, or we can instead of having to go back up there to find the frequencies, let's set up individual frequency tables. Okay, and we need to break it down. So I'm going to create two frequency tables. So pivot table 1 is here. Okay. And we'll do prior legal trouble. Okay, we're not going to do a joint. So earlier we did prior, and within that size, large or small, right? Or first we had large or small, and then whether we had prior or not. So now we're gonna do this. All right. So now we have the frequency table for. So this is the marginal probabilities for legal trouble. Okay. Then we'll do marginal probabilities for size. Size, status, all right, now let's define some probabilities. Okay, so probability of the event. So this let's see. Fraudulent or truthful. Okay, so that would be probability of F and probability of T. Then you have size equal to large and size equal to small. So we will need probability of L given F and probability of L given T. And then probability of S given F and probability of S given T. Okay. So earlier we had the joint probabilities, now we are breaking them out into the individual probabilities, right? And then prior equal to no, and prior equal to yes. So now we have probability of no given f, okay, probability of S given f. So this will be probability of no given t, probability of S given. So these are the probabilities we need, as opposed to in the exact we looked at probability of L and N given T, L and N given F. So now we are doing L given F and N given F. So that's it. So there is no joint probability. Okay, so these probabilities are now, so we can compute these probabilities. Probability of the event is, that's the same as before. So fraudulent is C85 divided by E85, and truthful will be 1 minus that. So that's our prior probability. Okay. So now L given F. Okay. So now it is large or small, right? So that's this table. L given F will be that divided by that, C90 over C90. Okay. And then C91 over C92 will be size S given F. If you copy that over, you will get truthful. So this will be that divided by that, and then 4 divided by 6 will be that. Okay. And then here, no given F. Okay, so no given F will be C83 over C85. So this will be C84 over C85. That divided by that. So now if you copy that over, and you get that probability, 5 over 6 and 1 over 6. Okay. All right, so now we still have the 4 cases. So we have the prior probabilities. Right. So we have fraudulent is 0.4 and truthful is 0.6. Then we get case 1. Suppose if our case is L and N. So now using naive method, how are we going to calculate the posterior probabilities so we can make a classification? Now instead of looking at L and N given F and L and N given T, so we're going to use these probabilities here. Okay. So we have probability of size given well, so we have size and prior, right? So these are the, so size is L, prior is N. So that's the case that is presenting our, well, size equal to L prior equal to, we'll use these for probability. So now we have size is L, so L given F, okay, L given F is that, and L given T is that. Now N given F and N given T. So now joint probability so it's the product of these three now. So all the conditional probabilities, multiply all the conditional probabilities. Here we have only two because there are only two predictors. So you will have as many conditional probabilities as the predictors. If you have 8 predictors, you will have 8 conditional probabilities. Okay. So in the exact Bayes, we will have only one because all of them taken together given T and all of them taken together given F. So now you have individual probabilities and then you multiply. So there is a function, if you have lots of them, you can use the product function. If you have only one or two, then we can just simply multiply them. So like multiply all the conditional probabilities and then finally you multiply the marginal probability. Okay. So that's our overall joint probability. Okay. Now adding them will give you, so this is your, in your Bayes theorem table, the joint probabilities are like these, approximations of these. Okay. So instead of having just two probabilities, conditional probabilities, we'll have, so in this particular case, because only two predictors, then we had 2 and 2, whereas otherwise you'll have as many as the number of predictors. So you add these two, you get your marginal probability. So probability of L and N here will be the sum of these two. And this is not exact, okay, because it is naive, this is approximation. The posterior probabilities, then, and this is what we have to use for classification. So same way you divide that into that. Of course, these two should sum to 1. So that's case 1. And we repeat the same process for the others.